And welcome to the Smash News Network, least busted name in news. This is the daily space weather. Today we're talking about Sunspot 2808 in the Northeastern Limb, Heliophysics, and cosmology. By the way, thanks to everybody who voted in our polls yesterday. We got unanimous votes that this area down here in the southeasterly portion of the sun right there would become a sunspot, but it has actually evaporated. But guess what has happened? We've got a sunspot in the northeastern limb instead. So just when you thought there'd be zero sunspots, another one has appeared. This is one of my favorite views here. This is the 171 angstroms and colorized magnetogram composite. You can find these yourself if you go to the SDO data page. You find this Browse Data link under the Data tab. And again, that's 171 angstroms and colorized magnetogram. Here's a less exciting image, but for all you stargazers out there, right here, we see a sunspot rising just at the end of the at the end of the video there. That is an alpha class sunspot. So more in-depth analysis about that and all kinds of other stuff here on the Daily Space Weather coming, including this great HelioViewer movie, a full disc view of the past 24 hours. Similar to what we initially showed you, but without the colorized magnetogram superimposed. And we'll show you the southern hemisphere and the northern hemisphere, and then we'll blast through a whole bunch of data. Southern hemisphere, you can see Sunspot 2806 setting over there on the right of your screen, and some minor filamentary behavior in the lower left of your screen, the southeastern limb. And we call that the east because that's where space weather rises. The west is where space weather sets. The directions are heliocentric, folks. This active region up here is just a plage, not a sunspot, but that area rising there is definitely a sunspot. It'll definitely get named 2808. It's not going to evaporate all that quickly. And let's talk about things like your orientation. Here's what's currently going on in the solar system. And there's where things will be in a week. It'll be a crescent waxing in terms of moon phases as Venus slides around to the backside of the sun from the Earth's perspective. And we like our viewers to have perspective. It's part of the reason why we make the videos. If you're up before dawn, you may see the moon and Saturn. And please leave us a comment. David Icke, if you're viewing the videos, David Icke, leave us a comment. We'd be more than happy to have you as a guest. And leave us a comment if you think I'm a reptile, as I've suspended my growth of scales recently to be more presentable for you, the viewer. The 10.7 centimeter radial flux has jumped back up to 80 solar flux units. And for you new viewers, that's a measurement of the outer chromosphere and the lower corona. So just this very small portion of the sun right about here. The lower corona and outer chromosphere is where the 10.7 centimeter radial flux is emitted from. Let's put it in context. Here's a one-year chart. This black line is the radial flux. It's the most significant measurement of solar activity besides sunspot number, perhaps even more important, but in any case, the red line here is sunspot number. You can find that graph on solon.info. And I just wanted to show you the Space Weather Enthusiasts dashboard real quick. The imagery from the LASCO C3, part of the SOHO spacecraft located at Lagrangian Point 1. Great view of Venus there. Let's see what's erupting here on planet Earth. Will you be saying, "Oh my God"? You might be. There's a bit of a volcanic uptick, especially in places like the Philippines, as Pinatubo has had its alert level raised in the past few days. Let's scroll down the list here on VolcanoDiscovery.com's Volcanoes of Today. Klyuchevskoy on the Kamchatka Peninsula is still on the list. No significant changes in activity. Some eruptions happening there regardless. Gas, steam plumes, and ash, as well as lava flow on the Kamchatka Peninsula. Sakurajima on the Isle of Kyushu, producing an 8,000-foot ash plume. Suwanosejima in the Ryukyu Islands, 6,000-foot ash plume there. And Tal volcano on Luzon in the Philippines archipelago has had its alert level raised to orange due to ongoing elevated seismic activity under the volcano during the past 3 weeks. The main crater lake and acidity was at a maximum of 77 degrees Celsius with a pH of 1.59. Continue to increase, caused by volcanic gas reaching shallow hydrothermal system that feeds into the lake, accompanied by degassing. So small uptick there at Tal, alert level raised to orange. Mount Ibu in Indonesia, flight level 070, it's producing a 7,000-foot plume of volcanic ash. Dakono's exploding as well. 8,000-foot ash plume there. Don't pole vault your ash over the ash. You might become ash. Veniaminoff on the Alaskan Peninsula, volcanic emissions continue there. Popocatépetl down in Mexico is exploding. 20,000-foot ash plume. Pacaya, Strombolian explosions. Strombolian activity at Sabancaya down there in Guatemala. So that's a change in the behavior of Sabancaya, the Guatemalan volcano. It's also producing a dense dark ash plume rising to an estimated 16,000 feet of altitude. Fuego in Guatemala exploding. So a second Guatemalan volcano there, Fuego, 15,000-foot ash plume. Sangay exploding in Revenador, 20,000-foot ash plume. Revenador exploding in Ecuador as well, 15,000-foot ash plume there. And Sabancaya, one of the most active volcanoes in the world, back to exploding, 26,000-foot ash plume. Please don't pole vault the caldera, and leave us a comment if you would be interested in a t-shirt that says, "Please don't pole vault the caldera." I was going to make it yesterday, but I made a video about censorship instead. Perhaps you noticed it, or who knows, perhaps it was censored. We don't know why the Smash News Network gets censored. Apparently, citing facts is extremely controversial in the year 2021, year of accountability. So make sure that you hold the appropriate parties accountable. Let's hold Earth accountable and see what's been going on seismically. Well, tons of aftershocks in the Kermadec Trench, north of New Zealand there, and south of Tonga. Otherwise, I don't think any major quakes happened. Indeed, they didn't. A deep quake struck Chile, though. It's a 5.2 magnitude at over 100 kilometers depth. And I'm just going to scroll up the list here. This is one of the largest, at least one of the largest, not occurring in the Kermadec Trench. This 5.5 happening at Indonesia. And we're not encouraging folks to not attempt to forecast earthquakes. We just don't believe anybody is forecasting earthquakes. We've looked at everybody's systems and everybody's data sets, some of them even daily, and we do not see the correlations that folks claim are there. Here's an extremely shallow quake at Stovepipe Wells, California. Check it out. It's at an altitude of 1,400 meters above sea level, a depth of negative 1.4 kilometers, folks. So there it is. It's right near Death Valley, folks, near the Nevada border there. An earthquake happening at an extremely shallow depth, only a 3.2 magnitude, but at a depth of negative 1.4 kilometers. Small deep quake strikes Pakistan. It's a 4.2 magnitude. Vanuatu saw a deep quake at a 4.6 magnitude. That was over 200 kilometers depth. So we saw some minor solar flares here. A couple of B-class flares happening there, very small B-class flares. The likelihood of solar flares hasn't gone up that much, and by the way, the likelihood of coronal mass ejections isn't that high either. And I'd tell you why, but I would divulge our system for forecasting coronal mass ejections, and I won't do that. At least not yet. Perhaps in a later video. The proton flux remains flatlined, and we would have known about this before it happened because, again, we forecast coronal mass ejections here at the Daily Space Weather. The GOES magnetometer over the past 3 days is looking fairly smooth here. The Earth is solidly in a South Pole-oriented heliospheric current sheet. We'll show you a visualization of that on the next slide. Nothing too exciting happening there on the GOES magnetometers, as measured by the GOES 16. Actually, the next slide is the real-time solar wind. I stand corrected by myself. And I don't mind being corrected. In fact, I like being wrong. It means that I've probably learned something. So in any case, I don't double down on my nonsense when I'm incorrect. I abandon my nonsense and move on with life instead of gaslighting myself and others. And I just want to check the life of the stream here before we go into the real-time solar wind. And everything looks just fine here at the Smash News Network. Least busted. Name and news. So over the past 24, we've seen a fairly steady solar wind, although we saw a recent uptick here in the past couple of hours. Current conditions are 474 kilometers per second for the solar wind speed. Solar wind density, just over 5 protons per cubic centimeter. And some minor shifts in the phi angle here associated with that recent small uptick in solar wind speed. Here's the KP index, and again, we will get to that magnetic data here momentarily. KP index coming off of its lows of 0, now at 1. And for you new viewers, the KP index is a measurement of global geomagnetism. So here's a geospace magnetosphere movie. It's 4 hours of data. And we may see a small uptick here in the pressure accompanying that increase in the solar wind speed. And you see a small uptick in the pressure there. This is in nanopascals. Again, it's 4 hours of data. Nothing to write home about there. Next, looking at perturbations on the globe, changes in the Earth's B field, otherwise known as geospace delta B. Since we're living a polar excursion, a geomagnetic polar excursion, we show this daily as well, and I'll let that play all the way through as it refreshed for your convenience. And here's that magnetic data we were talking about. It's the Gong 2 data. And we're looking at the heliospheric current sheet here. You can see the Earth solidly in a South Pole-oriented current sheet, shown there in red. Keep in mind the data is 1 hour and 7 minutes old and can change rather suddenly, especially with things like sunspots. Here's a line of sight coronal hole plot. This shows you the sun's B field. Earlier we looked at changes in the Earth's B field. Now we're looking at a visualization of the sun's B field, which is shown in blue. And you can see a coronal hole rotating in there. It's red, it's South Pole oriented, and we can expect some coronal hole wind from that in a couple of days, about 3 or 4 days most likely, from that small coronal hole there that you can see in the south. Now, if you want to see what was going on with the sun's B field 11 years ago, at this same time through the progression of cycle 24, early in the cycle 24 cycle. Check out our solar polar fields now versus 2010, completely incongruent to previous cycle field progression video. Here's a clip.
There are the fields left.
And we showed various different data sets
And it's
about what the sun was doing then
now. So I just figured I would.
and what the sun is doing now.
I certainly didn't. And here's what the sun.
And that's what the sun looked like exactly 11 years ago. So check out that video if you haven't. You can find that on our playlists. And we don't see the new Sunspot here, Sunspot 2808. We don't see that one mentioned yet. It's barely risen on this imagery here. This is the Integrated Space Weather Analysis Center. And what this is the ASSA detected sunspot groups and magnetogram. You can find that at the Integrated Space Weather Analysis Center. By the way, this video was streamed live to Twitch thanks to our followers over there. It's twitch.tv/smAsho. If you're viewing on YouTube, don't forget to press like and subscribe. Press the notification bell and tell your friends, foes, science noobs, and perhaps science pros about the channel. We're doing something nobody else is. And quick note about that. We saw a niche when it came to the daily space weather, and we saw something that nobody else was doing. In my opinion, nobody was looking at the correct data sets. So we have very specific data sets that it's taken us, indeed, years to show the tabs daily that we show. And that's part of the reason why the channel exists. But there's also lots of other content you can find there on the playlists. Don't forget to follow us on Instagram. Maybe get us to, 500 followers, as if that's some kind of a milestone on Instagram. As we cited the censorship that's been happening recently, as our own comments have been getting censored on our own channel, despite not saying anything even close to issues with the terms of service. And we're also on BitChute, by the way, bitchute.com/smAshomash. If you ever see one of our videos mysteriously vanish, just type in bitchute.com/smAshomash, and you may find it there. There is exclusive content on BitChute, which you can no longer find on YouTube because of things like demonetization. So we are alt tech folks, and don't forget to check out our own websites as well. smAshomash.org will redirect you to smAshomash.com, and you can find all of our links to our social media as well as our stores. And we're going to talk about radio galaxies in a brief moment. One of our stores, the smAsho store, which you can link from the homepage, is so interested in radio galaxies that we've created the 3C405 shirt. As you may not be aware that Cygnus A, the radio galaxy located over 500 million light years away, is the second strongest radio source in the sky, second only to the sun. And we want to get important information like this out to folks, so we've featured some astronomical stuff on some of our products. Again, you can link to all of that at smAshomash.com. So let's do a cosmology segment, as there are some interesting stories to cover once again. And we like interesting stories, so let's cover them. All right, so the most distant radio galaxy ever seen has recently been discovered. It's located at 13 billion light years, and this is an artist's rendition that you're seeing here. It's Quasar P172 plus 18, and this gives me a great opportunity to show you that you are located someplace in this jet. Otherwise, it wouldn't be a quasar. And really, if you are located about here, that's a quasar, and if you're located just a little farther over there, it's a blazar. It all just has to do with how bright it is and your orientation. If you were oriented, say here, it would look like a Seyfert 2 galaxy. If you're oriented here, maybe a Seyfert 1 galaxy. Now this is odd, as we usually see radio emissions from these quasars when we're located at a perpendicular angle to the poloidal jets, which are shown here in blue. Those are the polar field jets, the poloidal jets from that radio galaxy. And in any case, P172 plus 18 must be a pretty organized galaxy, or it wouldn't have jets like that, right? So how is it 13 billion years old? Does this fly in the face of the age of the universe and the Big Bang? Well, indeed it does. And you can find this article on SciTech Daily. It's probably on other science wires as well. And the estimated mass of the core of the massive radio source located at the core of that galaxy is estimated to be 300 million times the mass of the Sun. And we try to call things massive radio sources, something that I noticed in the mid-1990s. Some folks were calling massive radio sources black holes, and other folks continue to call them massive radio sources. I won't get more in-depth into that in today's cosmology segment. Perhaps you'd like to check out the article on SciTech Daily. It's right on their homepage today. And let's pick a random number between 1 and 1031. How about 620? Why? It coincides with an object at the Neil Gehrels Swift Observatory, the Burst Alert Telescope. So what's 620, you ask? 620 is RxJ 1709.5-2639, a low-mass X-ray binary. So most likely a star in the Milky Way galaxy. And look, this is very interesting here. So this particular star, this low-mass X-ray binary, had a period when it stopped emitting X-rays for like over a year, nearly 2 years. RX 1709.5-2639 shut down in terms of X-rays. Now, apparently this is a thing that it does regularly, because look right here on the daily graph, you can see it shut down there again. So this is an interesting variable star here, to say the least. And here's the 30-day chart. You can see it maybe has some 30-day cyclicity going on there. In any case, maybe we'll have to look more in depth into this one. RxJ 1709.5-2639, a catchy name. Let's take a look at it on Aladdin Light. And not a lot to see there invisible. How about an infrared, which often shows us more? It's the 2 mass. And we don't really see jack on the 2 mass either. Let's check its X-ray outputs. How about the multi-mirror project? Nope. And not really on Chandra either. Let's look at it in blue light, as sometimes blue light gives us additional information, and not really. It's pretty dark in most wavelengths, folks. So that's today's random, quote, random cosmic object in today's cosmology segment. And thanks for leaving comments. John Kotowski, one of our patrons, aka Life Force Rejuvenation. Perhaps check out his YouTube page as well. And we've got one more story here. I just want to briefly talk about the Primer fields. So you may have heard of the Primer fields. It's David LaPointe's work using specially made magnetic cups. And here he's gonna blast dark energy.
Will also eject matter at high velocities.
And the Primer fields is one of the theories as to how things like galactic jets form. So perhaps watch the Primer fields part 1. And by the way, if you're one of those folks out there who believes that stars are electric, and you're sending me links to David LaPointe's work, or perhaps Pierre-Marie Robitaille's work, you may want to know that neither of those guys think stars are electric either. David LaPointe and Pierre-Marie Robitaille do not believe stars are electric, and neither do I. We're more interested in their fundamental nature, and we would probably see all kinds of evidence if stars were electric. And one of the reasons why we study the sun so in depth is because I consider the sun to be cosmology. So, heliophysics, until we understand the way the sun behaves, folks, we're not going to understand cosmology, as all cosmology is based on the evolution of the sun. So the similarities between the sun and other stars and so on has to do with the way all of cosmology is, quote, understood, end quote. So here's an article on universetoday.com talking about very detailed analysis, magnetic analysis of the chromosphere. So we've got two different orbiters right now, the Parker Solar Probe, which is the fastest object ever built by mankind, and the ESA's solar orbiter, and they're both collecting lots of data right now. And what's going on inside the sun is kind of important in that the sun is the Rosetta Stone of cosmology, folks. And until we have a reasonable explanation of the sun's behavior, the idea that we know what's going on in the cores of distant galaxies is just insane. And it's not to say that the work of all modern astronomy is just pointless. That's not true at all. The data that they're gathering is more than relevant and more than useful. It's just that until we understand heliophysics, the idea that we understand what's going on Deneb, or what's going on at Sagittarius A star, or what's going on at the core of the galaxy 3C405, otherwise known as Cygnus A, the second most massive radio source in the sky, is just silly and insane. So, more about this later. Maybe check out this article on Universe Today about space missions building up a detailed map of the sun's magnetic field. And that's today's cosmology segment. We don't want the daily space weather video to be too long, and so we're going to move back into more of the regular old everyday space weather data, like the relativistic electrons. So here is the one-year chart from Solon.info. The relativistic electrons in fairly moderate levels here. We saw mild warning levels yesterday once again. Pretty much the same warning levels as the day before. A little bit of a different chart there as the coronal hole wind stream subsided. There were less protons to perform chemical reactions with those electrons. So here is the the forecast model. And you can see we saw a little bit higher levels than in the forecast, and we're expecting an increase here. I would tend to agree with that forecast model. Here's a visualization of the electron content. This is the entire error column, folks. This will show you where likely GPS errors would occur. And the electron content is looking pretty normal to me over the past 24. Here's a diagram of the atmosphere, and that red F over there to the right of visible and IR electromagnetic radiation. That red F is indeed the F ionosphere layer around 300 kilometers where the GOES 16 makes its measurements. Here's a visualization of just the ionosphere. And we're seeing some pretty rapid charge ups and charge downs there. Keep in mind the resolution of this is only 1 megahertz. Each one of those blobs coincides with it's an ISO frequency, similar to an ISO bar on a pressure map for meteorology. But we're looking at vibrational frequencies here, megahertz. Some rapid charge ups there over places like South America. And if you see oddities in this area, or in this area, those are the two weakest spots in the Earth's magnetosphere, folks. The South Atlantic and now South African anomalies are the two weakest spots in the Earth's magnetosphere. Here's the latest image. This is from 10:30 Universal Time. Ionosphere looking fairly normal there. Next, we'll move into meteorology realms. Here are the jet streams of the eastern world. Jet streams still blowing backwards over the Indian Ocean, east to west, but fairly coherent in the northern and southern hemispheres otherwise. A little bit doubled up in both of those areas. Here is the western world's jet stream scenario. And we see doubled up jet streams over the U.S. We see extreme meridional jet stream flow over the northern portion of the Atlantic. Look at that S-shaped bend there, as well as some pretty cold air being injected into southern and eastern South America. And continuing on with meteorology, here is the GFS forecast for pressure. Here's where pressure cells are now. And here's where we expect them to be at 12 noon tomorrow. And that's noon Eastern time. A double, powerful, large, low-pressure system there in between Scotland and Greenland. Probably making for some rough seas in the extreme northern Atlantic. And I like to use windy.com for my pressure maps. Next, we'll look at a real-time lightning map. I use lightningmaps.org. If you have an alternative site for real-time lightning maps, let us know in the comments. And we see pretty light lightning here, as in not a lot of lightning. Really, over the past 2 weeks, we've seen quite low levels of lightning here on planet Earth. I would note all the low clouds once again. Check out all the low clouds. These are all low clouds, this whole area here, as well as these. These are all low clouds, folks. Low clouds are associated with cosmic ray flux. We'll cover cosmic ray flux in a future video, probably tomorrow. As energy from space can cause clouds to form, those protons and other associated particle showers create ionization pathways. Ionization pathways affect the way water behaves in the atmosphere, and that can cause clouds to form. Check out the weird weather here over places like Colorado, Kansas, the Oklahoma Panhandle, the Texas Stovepipe, and northeastern New Mexico. We have a stagnant blob of dry air right there. And there's some hot air coming from the south. Please leave us a comment if you've noted a lot of hot air coming out of southern Colorado. But there's some hot air coming from the south. And it's colliding with this dry mass of air here. And that's part of some sort of an upper level low. This must be a very powerful upper level low pressure system right here over western Mexico. As you can see, these cloud bands are making it over the top of that dry air. That dry mass of air must be close to the surface. So it's a surface high, there's a temperature inversion, and all kinds of weird pressure gradients going on there. You may see some weird cloud formations in places like southern Colorado, Kansas, Oklahoma, Texas, and northeastern New Mexico. Leave us a comment if you find some weird cloud formations. We may feature them on the channel. Here's a U.S. Doppler radar map. And we see some snow there in Maine, as well as in the northern Rockies, and a bit of precipitation in the northwest. It looks like some possible wintry mix close to where I am. And if you're a new viewer, we're located, Smash Staff and I, here in Lehigh Valley, Pennsylvania. Shout out to Smash Staff. Shout out to Granddad, as my nearly 93-year-old grandfather may know more than you about cosmology. Who knows? Next, thanks to our patrons, the true source of funding for the content. Thanks very much, patrons. Thanks everybody who does one-time donations on PayPal. Sorry it takes us so long to account for that. We've sent out emails this morning to our PayPal donors. You can find links to all that stuff once again at the homepage, smashomash.com. Seriously, thanks very much, patrons and donors, as we make just this side of nothing to put the videos on YouTube. But they're there anyway because people watch them. So we've got bonus features here. We're going to show you a high-res image of the local yellow dwarf's colorized magnetogram, as well as the intensitygram. Here is Sunspot 2808. It's still alpha class, as I only see one umbra. It is a North Pole umbra. And welcome to Cycle 25. Welcome to the Neo-Renaissance. Here is the colorized magnetogram. And there's the intensitygram once again, and there's the magnetogram. I changed my mind. I think it's a South Pole. I think it's a South Pole umbra, folks. But in any case, we'll be keeping an eye on that. And when I say ion, well, the pun is intentional. And we've got a couple additional bonus features here. Zoom-ins of the most recent activity. Here's that new rising sunspot. Currently only alpha class, the likelihood of major solar flares pretty low. Again, the likelihood of coronal mass ejections quite low as well. If that changes, we'll let you know. Here is 94 angstroms, that same exact area. And here's 94 angstroms, the setting, sunspot 2806. Give that a minute to load. There we go. And I think the most recent minor B-class solar flares came out of 2806, not 2808. And we'll close things out with one more view, probably the most aesthetically pleasing view here. 171 angstroms, plus the Earth scale there to show you the size of those filamentary loops. It's about time to close this thing out. Thanks for tuning in, folks. Remember, stare at the sun, don't drink, but if you do, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance, and may that solar wind be at your back.